We're going to discuss Cramer's rule of 3 equations and 3 variables. Now, if you've ever done a system of 3 equations, you know you really have to pay attention. We're at 13.3D. I've got 7 previous videos that are linked in this description in case you need to watch them. The previous one right before this one's kind of important. So Cramer's rule uses determinants to solve systems of 3 equations the same way we solve systems of 2 equations. The determinant of a 3 by 3 matrix of coefficients can be used to tell us whether a system of 3 equations in 3 unknowns is consistent and independent. That means the lines meet at a single point and there's a single solution. So here's Cramer's rule. It's kind of big because we've got 3 equations here. So the system of 3 equations and 3 variables, you can see our blue one here is marked with sub 1, and our red one is sub 2 because that's our second equation, and then this green one is our sub 3's, and that's our third equation. So we've got the first one is blue, the second one is red, the third one is green, and hopefully that's going to help us tell them apart. Now, we're going to get a solution by doing this d to the sub x over d as a quotient, and then we're going to do y as a quotient of d to the sub y over d, and then z is the quotient of d sub z over d. Now, we're going to get this d by solving this 3 by 3 matrix. If you don't know how to do that, you need to go back to 13.3c. That was the video right before this one, and I explained how to do that, okay? And I'm going to do it a little bit in this one, but if you get confused, just go back to the previous video. So, now, how do we get these numerators? We do it this way. And d, you can see here, is what it equals. It's what each equation equals. So you can see the d values here, and the d values here, and the d values here. See that? The lowercase d's. All right? So we're going to use these as templates to help us solve them. All right? So I want you to notice that the determinant d sub x here, this is the numerator. See that? Right here, it's the numerator. This one that we're using. We're going to substitute the constants, this d sub 1, d sub 2, d sub 3 for the x coefficients. And when we get this d to the d sub y here and this d sub z, we're going to do basically the same thing in a similar way, okay? We're going to use these for the y values, these for the z values. See that? So now we've extended Cramer's rule to solve a system of 3 equations in 3 variables. All right, a couple of videos ago we did 2 equations in 2 variables. So we're going to put some real numbers in here, and boy, you're going to have to really put your thinking caps on and try to stick with me here. So we're going to solve this system using Cramer's rule. So here's our system of 3 equations. We know there's a 1 here, we have a -3 and a 7, we have a 1, and a 1. We have a 1, a -2, and a 3. Pay close attention to these negatives, okay? You don't want to accidentally put a 2 here when it should be a -2, because then when we go to put these values in, we could get the wrong answer, all right? So the first thing we're going to do is find d. We're going to find our denominator, and we're going to use this template right here, where we've got the ABC values for each equation, okay? See that? How they're all in order? A sub 1, B sub 1, C sub 1, see? And then 2, and then 3. So we're going to use that to find the d. So we put in our 1, our -3, and our 7. And then we've got a 1, and a 1, don't we? For the second equation. And from the third equation, we've got a 1, a -2, and a 3. Now we're going to solve this as a determinant of a 3 by 3 matrix. And this inside this box, in this rectangle right here, is our guide. And boy, is it really important, because we're going to keep reflecting back on this. So if you don't have this written down, you really need to. This is how to solve a 3 by 3 matrix, okay? So the a sub 1 times these values minus a sub 2 times these values, and we're going to get the determinants from each one of these matrices, all right? And you do that by cross-multiplying here, and then cross-multiplying here, and we subtract that product from that product, all right? So we've got our B sub 2 and our C sub 2. See that? That's a 1 and a 1. And then we've got a -2 and a 3. So we're going to cross multiply. So we've got a 1 times a 3 and a -2 times a 1. We have to subtract these. All right? We're going to do the same thing for this one. We're going to cross multiply. -3 times 3. And then the -2 times a 7. See that? And we're going to subtract those products. Then we're going to add this 1 times the difference between this product and this product. All right? If you're confused, you have to go back to that video and watch what we did. All right? So this becomes 1 times 5 minus a 1 times 5 plus a 1 times a -10. That gives us a 5 minus a 5. That's a 0 plus a -10. So we know the value for D is a -10. We know our denominator is going to be a -10. Now we find the D sub x1. And using this as a template, we've got our first D value, then the B, then the C. The second D value, then the B, then the C. See? We're going to use that as our template. We put in our values from the system according to how this is, and this one, and we get 13 times 5 minus 1 times 5 plus 4 times a -10. That's going to give us a 65 minus a 5. That's 60 minus 40. That's a 20. So we know D sub x is a 20. We do the same thing for the D sub y. We follow this template, okay? And at the end of the video, I'll freeze on this so you can copy this down if you need to. We use that. You can see the D values, the lowercase d values are now in the center. See the 13, the 1, and the 4? Before it was up here. This one, it's going to be down here. And we do our multiplication and our subtraction. We get a 1 times a -1 minus a 1 times an 11 plus a 1 times a 6. We do our math and we get a -6 for that D sub y. Now notice there's a little asterisk here. For this one, we use this as the template. Notice the lowercase d values are at the back now, the 13, the 1, and the 4. We do our cross multiplication and our subtraction, and we get a -24. Now, the reason there's an asterisk here is if we know what these are, we can use them to find this instead of doing all of this, right? So now we know all our values, okay? We've got a -10, a 20, a -6, and a -24. We've got a -10, a 20, a -6, and a 24. So, if you remember, it said here in Cramer's rule that we find the x value with this quotient, the y value with this quotient, and the z value with this quotient. And it's easy to remember because this has got the x, this has got the y, and this has got the z, see, as a subscript. All right, so we're going to find the x value using these, and we get a -2. We get a 20 divided by -10, we get a -2. For the y, we get a -6 divided by -10. That gives us a positive 3/5. And for the z, we get a -24 divided by a -10. That gives us a positive 12/5. So that's our solution. -2, 3/5, 12/5. And actually, we don't need to do that d to the sub z, because once we find the x and the y, we can substitute their values into an equation to solve for z. See? That's why it had the asterisk. Now, you need to pay extremely close attention when placing each value into that matrix or into their matrix and to the values we use when multiplying. One wrong value placement will create a mess and the wrong answer. There's a lot of work to get a wrong answer just because of one little sign or one little number. So pay attention to your negatives and positives. And if you accidentally, put a positive 3 here, the whole thing is going to be out of whack. All right? So you want to really, really be careful of your values that are in the system. All right? So let me back out and show you this. So you can copy this if you need to. And you can copy that if you need to. I'll freeze on that in a second. So maybe you can even take a screenshot. Whatever will help you. All right. And then let me do this. So if you need to take a screenshot of this rectangle, this helps you solve a 3 by 3 matrix to get the determinant, okay? All right, so our next video is 13.4a. I'm going to be multiplying matrices, and I'm going to talk about scalar products. We've got 7 previous videos for Chapter 13 that are linked in this description. I'm going to add this to the Algebra 2 playlist. Don't forget that I'm on Patreon, and I've got YouTube fan funding and PayPal. And if you'd like to support the work I'm doing, I'd really appreciate it. And I'll see you next video. Bye.